Hello guys, this is the second part of chapter 1 science class 10 and the topic is balanced chemical equations. As we have read in class 9 that mass can neither be created nor destroyed in a chemical reaction, that is total mass of the elements present in the products of a chemical reaction has to be equal to total mass of the elements present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Therefore, magnesium reaction that we saw in the previous video, that is Mg plus O2 gives MgO, was unbalanced as it has not equal number of atoms of each element before and after the reaction, and so is called skeletal chemical equation. Right? So, the skeletal chemical equation is an unbalanced chemical reaction because the mass is not equal in both the sides. Hence, as it is not balanced, we need to balance a skeletal chemical equation in order to equalize the mass on both the sides. If we compare unbalanced and balanced equation by looking at the given example, that is H2 plus Cl2 gives HCl. Here on the left side, as you can see, two atoms each of H as well as Cl have been listed on the reactant side, while on the product side only one of those H and Cl are there. So, in this case, the reaction is unbalanced or skeletal. While on the right side, if we multiply HCl by 2, now we have two H and Cl atoms at both reactants as well as product side. The same has been listed in the table also. Hence, the reaction is balanced. Now we learn balancing a skeletal chemical reaction. Let us try to balance the following chemical equation. The reaction which is given to you is Fe plus H2O gives Fe3O4 plus H2. That means iron is combining with water to form ferrous oxide and release H2 gas. Let's go to the step 1. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Hence, we have got this as our equation. Now, in the step number 2, list the number of atoms of different elements present in the balanced chemical equation. For example, iron has 1 atom on the reactant side and 3 on the product side. Same has been listed. Hydrogen have 2 atoms each on reactant as well as on product side. The same has been listed. Oxygen has 1 atom on the reactant and 4 on the product side, which has been listed in the table as shown. In step 3, we would learn which element we should choose first to start balancing. It is often convenient to start balancing with the compound that contains maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Using this criteria, we select Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the RHS and only 1 on the LHS side. The same you can see in the table shown. Now, to balance the oxygen atoms, we have to multiply H2O by 4 because to equalize the number of atoms, it must be remembered that we cannot alter the formula of the compound or elements involved in the reactions. For example, to balance oxygen atoms, we can put coefficient 4 as 4H2O and not H2O4 or H2O whole 4. Now, the partly balanced equation becomes Fe plus 4H2O gives Fe3O4 plus H2. So, this is the equation now. Now, in step 4, Fe and H atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. To equalize the number of hydrogen atoms, make the number of molecules of hydrogen as 4 on the RHS. As the number of atoms of hydrogen on the reactant side is 8, if we add 4 to H2 on the product side, it will be multiplied by 2 atoms of H here and it will become 8. Hence, the number of hydrogen atoms would be balanced. So, the equation would be Fe plus 4H2O gives Fe3O4 plus 4H2. Now, examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is iron. Initially, the number of iron atoms on the reactant side is 1 and product side is 3. So to equalize Fe, we take 3 atoms of Fe on the LHS too. Right? Now finally, to check the correctness of the balanced chemical equation, we count number of atoms of each element on both the sides. 3Fe plus 4H2O gives Fe3O4 plus H2. So there are 3 Fe atoms both on the reactants as well as the product side. 8 atoms of hydrogen on the reactants as well as the product side. In the same way, 4 oxygen atoms on the reactant as well as the product side. Hence, the number of elements on both sides are equal. This equation is now balanced. This method of balancing chemical equations is called hit and trial method. In step 7, we have to write symbols of the physical states. Now, carefully examine the above balanced equation. Does this equation tell us anything about the physical state of each reactant or product? No. No information has been given in this equation about their physical states. So, to make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formula. The gaseous, liquid, aqueous and solid states of reactants and products are represented by the notations G, L, AQ and S respectively. The word aqueous is written if the reactant or product is present as a solution in water. Hence, after adding the information about the physical states of the chemicals, the equation now becomes 3Fe plus S plus 4H2O in the gaseous form gives Fe3O4 in the solid form plus 4H2 in the gaseous form. Now the reaction is completely balanced. Usually, physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above or below the arrow in the equation. For example, CO plus 2H2 gives CH3OH under 340 atmospheric pressure. In the same way, 6CO2 plus 6H2O gives C6H12O6 in the presence of sunlight and chlorophyll and oxygen. This reaction is also called as photosynthesis. Now we'll try to balance a new chemical equation. Let us try balancing out the following equation, that is equation 1 which is given to us is aluminium plus CuCl2 gives AlCl3 plus C. In the first step, we have to draw boxes around each formula. Now, we can choose AlCl3 for balancing. Taking Cl for balancing, we will multiply 3 with CuCl2 and 2 with AlCl3 in order to equalize number of chlorine atoms that now have become 6. Now, to balance aluminium, whose number of atoms on LHS and RHS are 1 and 2 respectively, let's multiply it with 2 on reactant side. At last, to balance out Cu, we would multiply 3 to RHS. Now, the reaction is completely balanced. Let's recheck. Aluminium atoms are 2 on the reactants and product side. Number of copper atoms on the reactant as well as the product side is 3 and number of chlorine atoms on the reactant as well as the product side is 6. Hence, the reaction is balanced now. We have learned balancing in this part of the video. Now, in the next part of the video, we'll cover the rest of the chapters. So goodbye guys and see you in the next video.